Hello, I'm Chris. This is Gross Models, and welcome to the third and final, probably, in my series of looking at the Neon Realm, the new kit from Inventor. No, not Inventor, craftingtable.com. If you'd like to pick your own up, then you'll find a link below and use my uh, code Gross Models to get 10% off. Worth it for you. They kick me back a little bit something as well, so it's worth it for me as well. Please pop along and have a look. If this runs out of stock, there are other kits available as well. The next one I'm going to be doing is this one, the Nebula Raiders, which I believe pretty much contains everything that's in the other one anyway. But go and pick one of them up because I'm going to be doing that one soon. So we are on day 8 or 9. I can't remember now. But let's go down to the bench. I've already built the wiring for it, which looks a little bit like this. We've got a button, we've got a light sensor, and a resistor. That's it, as well as wires connecting it all together, and obviously the main Raspberry Pico board down there, and obviously wires. We've got wires. We've got in the kit, in case you haven't seen my previous videos, we've got a selection of buttons, LEDs, and a couple of the light sensors. Not a great deal of components, but there's lots of things that you can do with just those few components. So that is what we have there. Let's have a look at the day's code. It is in fact day 9. So let's go across to the screen. Have a look at day 9. This is return with the Elixir, storing and retrieving data. So yeah, the story, I'm not worried about doing the story. You can read through that if you like. Go to the website yourself. It's craftingtable.com. You need to sign up for a free account, but that's obviously possible. So yes, it tells us what we're going to be using. This is for storing and retrieving. Write and upload a code to store and retrieve data using the Raspberry Pi Pico W. So yeah, that tells us what we've got to do. That is the circuit diagram that I have created. I have made one change to it, apart from using a slightly bigger breadboard, which just gives me a bit more real estate to make things on. I have wired it up differently. You'll see on there, I don't know, can you see my mouse? My mouse is not coming through on the screen there, I don't think. Oh, yes, it is. There it is. Yes, this wire here, instead of going to the red white line, which I always consider to be the positive, is in fact a ground cable. So I connected it to the top blue line because I figure that I get in my head always to use that as a ground. So I connected that to the ground rather than the live, and these ones obviously connected up to the same thing. It doesn't really make any difference. I just think it's like best practices to do that. So yes, we've connected up the photoresistor and the button, and then the code. Now the code, yeah, the code. The code I have made some changes to. I shall show you the code that they provide. Obviously, it's there. Look, you can see it. I don't understand much of it. Coding is not my thing. I'm trying to learn. Although this is a good, fun course, it's not the best in teaching all of everything. So some of it doesn't make sense to me and still doesn't. But I have got into the world of AI, and I've been using my AI to help me understand some of this a little bit better. So I do get the first bit of it. We're using the machine and importing time because we need to use time for most things. The photoresistor is just telling it where it is, basically, which pin it's connected to. Understand that. The button, again, it's telling it what it is, how it works, and where it is. It's giving us a file name, like data, .text. It's creating a text file on the board itself. This is not using any of the computer once it's uploaded, which intrigues me. I mean, it is basically a computer, the little chip, but there you go. So we're defining read sensor data. The light level equals what we get from the photoresistor. And it's returning a thing that we're calling light level. I understand that. That makes sense. Right. We're opening file name A as F. That's what I don't really understand. But we're writing data. /n apparently is to create a new line, but that doesn't seem to be working properly. So that's one of the things that I've changed. So that's to store the data. To retrieve the data, we open the file name, and then the data is reading the lines from it. I assume that's basically what it is. If there's an error, then try again, maybe. I'm not sure. While true, if the button is 1, as in if the button is pressed, we're going to read the data, we're going to store the data, and we're going to print on the shell, the screen, data stored successfully. Then we're going to sleep for 2 seconds, and then we're going to print retrieving stored data. We're going to retrieve the data, and we're going to sleep for 1 second, and then we're going to print up what the retrieved data is and the file content. So that makes sense to me. Vaguely, I sort of understand it. So that is what happened there. But it returned some strange replies to me. So what I did was I asked my AI. I said, "This is the code," and she told me what it does and what it should do. But then she suggested some changes. So let's have a look through the code that I've actually run, and we'll see what changes she has made. It's all the same file name. Right. Yeah, this is interesting. She's added. Yeah, added some codes, some notes, which is quite nice. Right, so added read light level from the photoresistor. Well, I knew that already. That's okay. Stores light giving data in the file. Yeah, I've got that. And that is the same as far as I can tell. Except she's print error storing data rather than not printing anything. So if there is an error, she's actually given an error. Nice. Retrieves all data and cleaning it up. Try open file name R. Let me just compare that. R as F. Yeah. F read lines. Yeah, that's the same. Strip new lines and convert to integers. Right, this is a new one. Integer is a number, isn't it? So that's, yeah, because she was returning the number and then /n as a print, which I didn't like. So she's sorted that. And print error of reading file not found. Okay, if there's a problem, she's telling me what the problem is, which is good. Then we're checking if the button is pressed. I knew that. A simple debounce. I think that's just making sure that the button was actually pressed. Yeah, confirm it's still pressed. So we're waiting 1/10 of a second. So just in case there's some sort of glitch with pushing the button, maybe. Made it a little bit more complicated, but she's explaining what's going on there. So restoring the light level, data stored successfully. Avoid repeated storage due to button hold. Yeah, so sleeping for 2 seconds, that's what that's doing. And then we're retrieving that. But we're printing it a little bit different. Printing retrieve data is, I'm not sure about that join map file content bit. That must just be tidying it up. And it does indeed tidy it up. Look, you can see down the bottom here, the most recently pushed button returns that line there. So if I push it again now, it says data stored successfully. Retrieving stored data, retrieve data is, and it's added an extra number to that. This was the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and the 10th time I pushed the button, it returned that number, which is the light level from that. As you may remember from previous tests on this, with bench lights on, my light levels are very high. I can't get it to go very, very low. If I cover it over as much as possible, let's do that and push this button again. Then it retrieves the stored data, and the last number now, as you can see here, was 61743, is now 48107 because I've covered the light level was lower. So that makes sense to me. Yeah, it's a clearer and easier to read than the code that they gave me. Let me rerun the code that they gave me. just to show you what that was, if I can get rid of all that, put the original code over the top of it and run that. Right. When I push the button, data stored successfully. Reading stored data. There we go. It remembers the code, the data from before. But yes, it just says, as I say, it's printing it in a strange format with the N, which I assume should be basically a return key to put it down to the next line, but it's not doing that. But yeah, it's okay. That's just printing out the file as it is. It's not tidying up the file internally. But that's okay. That's that. I understand how that works in a vague sort of way. I understand more than I did before I started, which is all I can really, really hope for, isn't it? So that was that. Let's have a look. Yeah, it sort of explains it, but doesn't really. Asking about the true loop again, but we already knew that. It's not really explaining about the new stuff. So the conclusion to the story is successfully storing and retrieving data, preparing for the final mission. Yeah, so that's okay. I vaguely understand that. So that was day 9. The final day is day 10, which we shall do in a moment. This is interactive lighting combining photoresistor buttons and LED. Yeah, we'll pop straight into having a look at it if I complete and continue. So we've got combining photoresistor buttons and LED. All the skills you learn to create an interactive lighting circuit using renewable energy sources. Okay, we'll understand how to integrate multiple inputs, photoresistor and buttons, and outputs, LEDs, in a complex circuit. Okay, so we need 2 buttons, a couple of resistors, jumper wires, multiple LEDs, and everything else. So, yeah, we'll see about the story. Not really about the story. What does it say we're going to do? Story connects components under irons, going to a circuit with photoresistor buttons and multiple LEDs. We already knew that. We'll use the photoresistor to measure ambient light levels and adjust the brightness of an LED using pulse width modulation. Buttons will be used to toggle different modes and control additional LEDs. That's okay. So we've got a circuit there that's quite nice and complicated with 1 photoresistor, 2 buttons, and 3 LEDs. I will strip down the board that I've got here now. I will rebuild that as it said on the picture and come back and see and have a look at the code and see what sort of sense that makes to me. Right, here we are with the new wiring, new board, new programming, and new everything. The programming took a little bit of correcting. Yeah, let me talk you through what this does. There's 2 modes. The red button controls the mode, which basically changes. Well, sorry, no. There's 2 modes and 2 other things. The red button changes which one of the LEDs is lit. Simply switches between the 2. The other one changes the mode from flashing on the red one to not flashing, but using the photoresistor. So the darker it gets, the lighter it gets. There we go. Let's have a look at the code. I will have a look at the code in the existing as they provide it, and we'll go from there and then try and understand it and then change to my updated version thanks to my AI. We've opened that. Write the following code in. We are telling it where things are. We'll get to that in a minute. Things are not where they say they were. I've wired it up as they pictured it, and it wasn't working. Yeah, the LEDs and the pins, the buttons are the other way round. So where it's got pin 16 for the LED, that's actually one of the buttons, as is the other one. So I had to change those around. It took a bit of troubleshooting to figure out why that wasn't working, but I got there in the end. Then it's reporting back the button state for button 1 and button 2. It's just setting out to read them. Read the light level from the resistor. and then sorting the light level based on maximum light level. I understand that. Then we're doing the duty cycle business with the light again. I understand that one. It's setting the brightness of it dependent on the brightness of the light. So on their code, it doesn't make much difference because it's all very bright in here. But then we're getting the values for the buttons, and we're working out what the mode is depending on the buttons. That makes sense to me. And button 2, we're again changing the LED value from not the main LED. It's only switching out the other LEDs. So we're turning one on or the other one on, depending on how the button is pressed. Makes sense. I understand that one. And if mode is 0, the main LED is controlled by the photoresistor. If mode is 1, the additional LEDs still do the same thing, but the main LED blinks, which is just a simple blink. Turn it half brightness and turn it off, and then loop and turn it back on again. So that's working at half brightness. If I do not that just changes those ones. That one changes it from flashing at half brightness, or have to get it during the right cycle, going up to bright. It will go brighter than that if it got darker than that, but there we go. So that's that. So that was their code. Let's now have a look at my code and see what we've got. Obviously exactly the same, importing everything. The correct pins for the LEDs and the buttons. She has added notes to this, which makes it nice and easy. Read the value, yeah, got that. Read the light level, got that. Now this, I did change something this, and she's gone back to the original one again. I changed the light level to make it brighter in the darkness and cut off due to the level of light. Can't remember exactly what she did. It was about the duty cycle and taking off the light level, but I can figure that out again. It's not a problem. Then, yeah, we've done the button thing, same as it was, changing it in and out, same as it was, and yeah, that is exactly what it was. So basically, it's correcting the code for the pins and adding some notes to let me know what's going on. But yeah, I do understand how that works now then. So yeah, all good. Took a little bit of getting through to it, but we got there in the end. So that is the end of the, well, say the end of the course. It's sort of the end of the course, but it's not. It's the end of the day 10. There are extra courses. Let's complete and continue on that. Yeah, so if we go back to the screen again, we have got bonus starter course, traffic light simulator, Morse code machine, night light, which we can do in any order or anything you like. I'm gonna get through it and work through to this Wi-Fi controlled bit, because that's the whole point of this board, is that it's got a Wi-Fi controller on it. So I'm gonna work through that. The traffic light simulator is basically just wiring up 3 LEDs, which I've already done on this one, and it's just changing the sequence of them, waiting for 5 seconds, turning them on, turning them off, turning them one on and one off, and yeah, that's easy. I understand that. I'm not going to bother building that one because it's easy. So I shall mark that as complete. The Morse code machine is a little bit more difficult. There is a video to explain that. So I shall look at that. It's basically just wiring up a button, but the code is the interesting part on that. We are just we're telling it Morse code, basically dots and dashes, and then setting the dot duration 0.2 seconds and the dash duration 0.6 seconds, and 1.5 at the end of a letter. But then it's more time reading the button. Yeah, I understand that. While the button is 0, keep going. If the button isn't, if it's a dot, make it a dot. If it's a dash, make it a dash. When it finishes inputting, return more string. So let me wire this up. Actually, I'm going to say keep the same wiring. I'm just going to change the code and make sure it's reacting just to this button, rather than anything else. So basically disconnecting everything else, but just worrying about where this button's going to. So I'll get the code in and we'll see what happens. Let me just rewire it, rewrite the code to get that the right button pin, and we'll see how that works. Okay, I have reboarded. I got rid of all the old stuff because it wasn't working properly, and I noticed maybe why. There is a resistor on this version of the circuit which seems to be just grounding the button, probably to get rid of any extra problems with it working. It's still not working 100%. I'm not entirely certain why. I put it down to user error on this particular one. So we'll see, what happens. Let's go to the code. We'll have a look and see what we've got. It does make sense to me, again, in a vague sort of way. We've got, where are we? Start at the beginning. We're importing everything again, obviously. Telling it where the button is, and setting the button up as the type of button it is. Programming in all of the different types of code, dots and dashes, for all of the alphabet and numbers and common symbols as well. I wasn't aware, but obviously it makes sense that symbols do have to have their own code. Some are a bit complicated, but there we go. So dot duration is 0.2 of a second, dash duration is 0.6. That seems a little bit close to me. I think I'm going to change that and make that, I'd say that called 0.8. Make it a bit closer to a second for a dash. It makes typing it in slower, but it works. Well, it might work. We'll find out. So this is while true, setting up the time and then sleeping for a fraction of a second between. If it's being held, we're looking at the start time minus time. Yeah, which is basically setting a start and an end and finding out how long that time is. And then reporting that back if it's, the right direction for a duration for a dot or a dash. Then when you let go of it, where you return the more string. That's the thing that's a bit tricky. End of letter duration. Right. The main bit. The more string is the interpret of the button press if it's a dot or a dash, I think. Then the key and the value in Morse code items, which is the thing that we set up at the beginning, that's Morse code mapping. If value equals something in the Morse string, print the value. If it's unrecognized, print what you actually got and the value. So we're going to print key and the Morse string, I think. I'm going to run this as it is. We'll see. Now, down the bottom there, you've got the running thing. Oh, you haven't. Let me move that up so you have. There we go. That's what I'm actually getting back. So we'll push it and see what happens. We get an E. Is E just a single dot or a single dash? E is a single dot. What's a single dash? Don't know. Let's try a single dash. So hold it down for longer. We get an E. And we get a D. D must be single dash. No. Dash dot dot is D, apparently. So I think it is getting occasional things. We've got N that time. N is a dash and a dot. So it is picking up what they call a bounce, which my AI did tell me about and write me a code to eliminate it, but I can't remember it and I can't be bothered to check it out. But so if I go dot dot dot, that should be an S, which it is a 5 apparently. Why is it 5? 5 is 5 dots. So there is something going on there. Try taking it a bit longer. 5H. Yeah, so it's responding and sort of reading, but the button is not activating quite right for that to work as it is. I'm sure there is some software way of making it work and figuring that out, but I don't know it. So yeah, we'll call that a day on that particular version. I want to get onto the bit that I really want to do, but let's have a look at the screen for the next day. We've got a Pico Nightlight. We've done basically similar to this already. It's going to turn the light on when it gets dark, isn't it? So yeah, I'm not going to worry about doing that one. Reaction time tester. It's going to be push the button as soon as the light comes on, I should think. There are videos for these, so if you want to visit the site and read them and watch them, you'll figure out exactly what's going to happen.
Hello and welcome back to another video in the
just skip through.
So I can do start time is equal to time.ticks. So the time function comes with a lot of cool handy.
I do find this a lot easier and better than the AI story idea in that he does go through what's happening and let you know what's happening line by line. So yeah, that I find more informative. You'll be talking through all of that. So yeah, let me have a look through the code and see if I understand it. It's going to be that time bit again, isn't it? So we've got time sleep for 5 seconds. Turn on the LED, and then start time minus time ticks. Ticks in millisecond. Oh, get the time in milliseconds. Okay, from when you start to when you push it, and when you push it, it's going to end the time, and reaction time, it will print it as a reaction time. I understand that. Right, let me go away, build this circuit, and then see how it works. Right, that took me a long time to get that working. I don't know why, but I was having trouble. The button wasn't registering, then the LED wasn't registering. I had lots of trouble with it, but eventually I've got it working. I've got the code in and done. I'll just send it to it, and then when the light comes on, you push the button, and it does tell you, look, if I go back to the code options, it will show me down there my reaction time 236 milliseconds. You do need to run the code again, then the light goes off, and when it comes back on again, coming on again now, is it? Right again. See what I mean? It literally worked, and then it didn't work. I have no idea why or what is going wrong with that. I thought it was wires not making connection. I've replaced different wires, and it did exactly the same thing again. And then it was working. I just had it working for a couple of times, and then it didn't. Let's unplug it, plug it back in. Get that reconnected. Where's my option there? There we go. Let's get that reconnected to that. Send it out again and see. There we go. It came on. I pressed the button. My reaction time was 272. I'm happy with that. A little over a quarter of a second. Fair enough. Yeah. Now I did once again talk to my AI, and she did give me a better code, which had a little bit of extra tweaking to it to randomize the time, because at the moment it's just 5 seconds before the LED comes on. Randomizing the time seemed like a really good idea. But yeah, I don't understand the code, so I'm not going to go around using code I don't understand, because I don't understand it. But I can see the variations that she suggested. But for now, that will do for that. What I will do will be to go back to the course. Where are we on the screen? Let's go to the screen over there. That's the reaction time tester. So I'm happy that that is that now. Mark that as completed. Next up, we've got the Simon Says memory game. It looks like 2 buttons, 2 LEDs, and it's going to watch the sequence and replicate the sequence. Right, I'll try it. I'll build the circuit up. It might look a little bit different to theirs on there, but I shall build it up anyway, and then see if I can get the code to work, see if I understand the code first. So let me get it built. Okay, I've programmed it and set it up. It wasn't working. I took off the resistors for the buttons. I think that's to help ground them a bit somehow, but it wasn't working with them down. It kept saying they were pressed when they weren't. But now it works without. So I've done it. There we go. Look, it's flashing because it's doing things. Let me bring up the code so you can see what it actually says me. Replicate the things. I think I did it wrong. There we go. Watch the sequence. Now replicate the sequence. I wasn't watching. That was wrong. That should be green for now. That one. 2 of that one. So it's 2 of that button. 2 of that one. And 3 of that one. So 1, 2, 3. 1, 2, 3. And then the other one. 1, 2, 3. And then the other one. Well done. 3, 1, 2. 1, 2, 3. 1, 2. Yeah, obviously glitched and I was doing it too quick. But yeah, you get the idea from that. Let's have a look through the code and see if I can understand it even a little bit. And we'll work from that. So we're importing the machine, importing new time. I don't know what new time is, a new random. Right, not sure about that. It's setting up the LEDs for pin in LED pins. So that must be because it's all right. LED number and half a second. LEDs, LED number, value 1. And then sleep for a duration. And then value 0, turn it off. And sleep for a duration. All right, and the duration we've set as being 0.5. So if we wanted to change the duration, we could just change that number from that. And the LED number, it's getting from, it's just being a number. It's 1 or 2. Doing the same for the buttons. For 1 button in enumerate buttons. Yeah, I'm not sure about that. The sequence, let's go back to that in a minute. I'll get him to explain that. The sequence, while true, print new round for the LED sequence. Sequence append new random rand int 01. Yeah, this is beyond me. I understand the flashing LED bit and getting the wrong sequence if you don't do it right. Let's go to him and see what he tells me about the Simon Says game. 6-minute video. We're not going to watch all of it. Going to go through the code.
Welcome back to yet another video in the Raspberry Pi Pico W MicroPython course on the Inventor website. Today we're going to be wiring up a memory game.
Yeah,
Yesterday was a very simple.
I've wired it up a bit differently, but there we go.
Buttons. And if you ever want to expand it later, down here where we, after we import machine, time, and random, we can go down here and we can say, let's just say you want to change it. We can add, another LED pin here and another LED pin here, etc., as we want to. Just make sure you have a corresponding button pin that matches up. In this case, but LED on pin 12 will be matching up to the button on pin 14.
Yep.
13 will be matching to 15, and if we added any more, make sure that you have a corresponding button pin
I understand that.
as you want to, and you can make this as many as you want or as little as you want. For our case, we're just going to be using 2 of each. Down here below, we have a interesting way that we will be setting up and defining all these LEDs and buttons by using LEDs is equal to machine.pin as an output pin, 4 pin in LED pins, which is defined up here. So basically this just sets everything in this array to be an output LED, and this sets everything in this array to be a input pull-up pin for each of the buttons. Now, the way the game works is it will start with a sequence of 1 or 2, and then we're going to, every time you get it correct, it will increase
one to it.
and increase and increase all the way up until you fail. And
Right.
so if you get it correct 10 times, then the length next time should be about 11. And if you get it wrong, then it'll decrease back to 2. And just the whole purpose of the game is to see how far you can go without messing up. Now, in order to accomplish this, we're going to need a few different functions.
Right.
One is we're going to need a function to flash our LEDs. And that very first one is just going to be half a second of turning the LED on and then the LED off. This function will flash the given LED number. And remember, this is going to be LED essentially 1,
Okay.
button 1, LED 2, button 2, etc., etc. Down here we have a function that we have to wait for the button press and then returns the button number. So let's say that our first LED is going to be red in this scenario and the second LED is going to be green. I'm just going to make this up as I go along, but let's just say one is red,
Yep.
2 is green.
Okay.
Now in the define wait button or wait for button, it's going after it plays its little sequence or plays whatever it needs to do, it's going to then go to the wait for button function. And this is all stuff that's logically down below as well, which I will get to in a moment.
Yeah. Okay.
When you press the button, let's just say you press the red button, and the red button is number 1. What it's going to do is it's going to return I is 1, and once it gets to the end here, so all it does is just says 4,
Okay.
and it goes through all the buttons. It says, is this button value equal to the one you noticed here? And at which index was it at? Oh, it was at index 2, because
Okay.
it was
So
index
that's
1 because it was red, or index 2 because it was green. If it was red, then it would just say 1,
We're giving that I the number
and then
to
it would
find out what
return
it
that
is.
in define wait for button. So
Okay,
whenever,
I understand
wherever
that
it was
a
called,
vague little bit. I wouldn't be able
which
to
is
write it
down here.
myself, but I do understand what they're trying to tell me, which is always nice. I don't think there's anything more really in there. So yeah,
Found that make it easy for
I understand how it's doing it, just not quite the coding to be able to do it myself. But I understand what they're getting at and how they're getting at it. Basically, they're giving each LED a number, calling it whatever, and then just comparing the button to see if it's the same thing. So yeah, let's have a look. A binary LED counter. I've done similar to this before. This is just going to be coding it slightly different in a Raspberry Pi way. So yeah, I'm not going to worry about doing that one. Machine pin, yeah, we're not worrying about that. Yeah, I'll just call that done. That's all right. I'm not too concerned. With brightness control, yes, we're going to use power width modulation for that, aren't we? Yes, PWM to adjust the voltage going into the LED. So again, I understand that. That's fine. Right, then we're going to do one without any wiring. Not much code either. So we're getting the temperature from machine. It's obviously got an inbuilt temperature reader, has it? Let's watch a bit of the video while I strip this circuit down to nothing.
Okay, everybody, let's get back to this stuff once again. I'm going to add a couple more spaces, and this is the entire program today, ladies and gentlemen. We have import machine, import time, and obviously we have this function called analog to digital conversion, adc.machine adc4. As we know from many times before, we're going to start by importing the ADC and time modules. The ADC module here will help us to read the analog values from pins and convert them to digital data. We shall then use a time module to introduce some delays into our script. And in here we have, for example, sleep underscore milliseconds 500. I can also just do sleep, and I can change this to 0.5 if you want it in the format that's not the underscore millisecond variety. exact same functionality. So we can use the following while true. In other words, this is just going to be our loop. We don't really have anything else in setup except for just setting
not going to be true.
the ADC to be the 5th ADC channel, because ADC4 is going to be the 5th ADC channel, which just so happens to be how we can read off of the built-in temperature reader on the Pico W.
Yes, it is built in, right? Okay.
So let's start with this function here. ADC voltage equals ADC read U16 times 3.3 divided by this. So let's start by reading the ADC U16, and that reads 16 bits of digital data.
Right.
As we've discussed earlier, when we read that value, we'll be getting a number between 0 and 65535, and a voltage range of 0 volts to 3.3 volts. Because remember that we output 3.3 on the Pico W. We don't have a 5-volt out anywhere on this board, similar to some of our other boards. So what we can do to calculate this is we can use this simple calculation that just takes whatever we read, and then we're going to simply multiply it by 3.3 volts divided by the maximum value that we can get off of the read here. Based on the equation we solved from the above, we can then calculate the temperature value in Celsius, and then finally we can easily convert that to Fahrenheit by just doing the simple basic Fahrenheit to Celsius calculation
the maths
of
behind it,
1.8 of whatever it is in Celsius plus 32.
So let's we'll check the wiring diagram. It's obviously very, very simple. We'll grab the code from that. Let's copy that. We'll go back to our code on here. We'll, instead of deleting it all, I'll just start a new code thing and we'll paste in that, which vaguely makes sense to me. We'll run that and see exactly what it says. It says across the bottom, the temperature, 24 degrees, 75 degrees. Feels colder than that in here, but it's under the lights and everything else. So yeah, I'd give it probably about there. Let me put my hand over it for a little while. That should pump it up a little bit. If I haven't got particularly warm hands at the moment. There you go. 25, 26. I believe that is actually measuring the temperature, the ambient temperature of that circuit. Should start going down again now, probably. Although, again, lights are on. So, yeah, 26, 25, 26. Blow on it a little bit. I'll make it go down. There you go. 25, 24. Yes, so that makes sense to me. I understand that. I know how the code works. The calculation is a little bit rough. I would have just worked it out rather than having to put in, I'd work out what 3.3 over 3.536 is and just have a single number in there to multiply it by. I don't know about that. Equals 27 minus voltage minus that over another calculation to do to work out Celsius. I don't know what it's actually measuring. Voltage, obviously, but yeah, so that's interesting. But that makes sense to me. That's okay. You don't have to see anything on the bench to figure out what's what, because there's no components needed at all. I stripped out all the wires and LEDs and things, and we don't need them. Yeah, that is that. I shall call that also completed. And that only leaves one more to do in this set, which is the Pico temperature reader Wi-Fi upgrade. This board has the ability, I'm tapping at it, you can't see me. This board has a Wi-Fi chip on it. So I can actually assume we're going to export the numbers we get over the internet. So what I'm going to do is grab all of that text from that. I can grab it properly. I can't grab it and roll it down at the same time. Let's grab all of that. Copy that. I shall paste that into my script writing, whatever they call it. I can't remember what they call it on this one. And then we'll have a look at his video and try and understand exactly what he's talking about as we go through.
Hello everybody and welcome back to the final video here in the Pico W Python starter course series. This is going to be the last video from us, at least for this 10 video series. I'm going to have a bunch of recommendations for additional projects after this. Ones that I highly recommend the community has made that you should check out, definitely look at. This is where we're going to be starting, honestly, the greatest part of the Pico W, which is the Wi-Fi module. The W in the Pico W stands for Wi-Fi. The fact that we can do a whole bunch of things that the original Pico could not, and that is we can set up a Wi-Fi server, we can turn on LEDs from across the world, we can do anything we want from the web in our web browser, and I'm going to show you exactly how that is done here today. So we're going to be taking a look at the following program. I've already set it up with my SSID and password. I just kind of hit backspace here. But you're going to need a couple of things to get this started. One is you're going to be able to connect. You need an ability to connect to a 2.4 gigahertz Wi-Fi network.
Yeah,
a lot of modern routers might try to mix the connections as 2 gigahertz and 5 gigahertz and just put it into one SSID and one password. Okay. And depending on what's trying to connect, it usually can handle it. There are occasions, though, where it's not very good about it, especially with things like smart devices, especially potentially with things like this Pico W. If you have them separated, you're going to want to connect to the 2 gigahertz network. The reason you want to do this is because the band on the Pico W only supports 2.4 gigahertz. It does not support the 5 gigahertz band. If you try to connect to a 5 gigahertz band connection, it will not work. Again, most routers, if not all of them, support both in modern routers. And if it's older, it will definitely have a 2.4 gigahertz, so you'll be fine. Just know that if you have a newer router and they're mixed at all and you have any issues, sometimes you need to make sure you're connecting to just a 2.4 gigahertz one. So with that being said, before we get any of those technical issues out of the way, we're going to go and we're going to introduce a few new things. We obviously have time. That's pretty normal. We have Pico 0, which is a new import. We're going to import the Pico temp sensor, which is essentially the exact same thing we did yesterday. Oh, and Pico LED, which basically just says, hey, you know those internal LEDs that we have? Yeah, well, we're just going to have a variable name for it now called Pico LED. You know that Pico temp sensor? Well, remember how we did this machine.adc4? That's kind of a backwards way to do it from yesterday. This is a technical way to do it.
Okay.
This is going to be the easy way to do it. If you want to do it a little bit simpler, you can just type pico temp sensor.read pico led. whatever, and that's going to be a lot easier, or .value or whatever the syntax is if I go down.
Okay, it's an easy way of doing it.
That's going to be a lot easier than writing all of this here. And if you want to change yesterday's code for fun, try changing it for a little import Pico 0. You can do that here. Now we can do the following. We can import machine. We obviously know this. And the last two is network and socket. And this is a little bit confusing because we're going to be needing to set up a web page. Yes, we're going to be creating an entire web page and hosting it on our Pico W. Like, I mean, literally, let's scroll down. We have the entire HTML
code
for the page.
Right.
We have a form action which turns a light off. We have a form action which turns a light on. We even have the LED state, which we can grab, and we have a temperature value, which we can grab, and then we have this inside. All of this is going to be inside of the body, and all of this is obviously end the HTML, start the HTML. All in this cool function called web page, where we pass in the current temperature and we pass in the state of the LED.
Right.
We also have this function here called def serve, where we're going to start a web server, and then we need to import connection. Connection is where we're going to open a socket on a specific IP.
I I've heard about these.
That IP is going to be given to us once we're able to connect. So in my case, I got 192.168.12.99. That's my local connection, so I can connect to it from a computer on the same network. But as much as I want to go through the nit and gritty of all of these functions, I can, and I will. You're free to skip over it, but TLDR version, I'm going to make this really quick here. We're going to start by connecting to the Wi-Fi network that we do here. See where it says name of your Wi-Fi network? Let's just say your Wi-Fi network is John's Wi-Fi.
Right, I've got to look this up.
John's.
I've got dodgy numbers and stuff as my network.
Family home. Then you can have the password is going to be, let's just say your secret password that you guys use for your Wi-Fi at home is soccer mom 4462. I don't know. You can just whatever your SSID and password is for that. Again, that 2.4 gigahertz network. Set those here before you hit upload so that it knows how to connect. If you just continue to see waiting for connection, and nothing happens, you don't see this connected message. Either something's typed in here wrong, or you're trying to connect.
I was going to say I don't know that number.
Network.
Yeah. Okay.
First, you want to connect to that network, and once you do, it'll give you an IP. It's going to return this IP. That IP is going to be necessary because we're going to need to then open a socket on port 80, basically allowing us to host a web page that we can connect to on port 80 using that same IP. Then we're going to, after we open the socket, we're going to return a connection. This is going to be the connection that we can host the web page on.
Okay.
Finally, we're going to serve this connection. And on this connection that we're serving, we're going to have a couple different functions that we're going to have. If the request is equal to light on, else if request, or we're going to turn the LED on. If the request is going to be light off, we're going to turn it off.
Okay.
How do we get these requests? Well, they're from button inputs on the web page. The web page has these button inputs that allow us to do form action light on, form action light off. These are quite literally physical buttons on the website. Don't believe me? Let's actually load up the website right now. Okay, perfect. Now we have the following code running, and this is actually exactly what's running on our board right now. If I hit the light on, believe it or not, it turns.
Right, I'm going to show you that I've stripped the board down. I've put all the bits away in my box for now, except for the board and the smaller breadboard I've gone to because it's, well, you don't even need it on a breadboard at all, but that's just going to save the pins from getting bent. So let me get this code up and running, put in my Wi-Fi details, which I'm not going to share with you guys because I know what you're like, and see if I can get that web page up and running and then see what we're doing. Okay, I have done it. I have uploaded the code. I put in my secret login details, put in the code. I've gone to the website that it kicked back, which was up in the top there, 192.168.1.140. And I have now got the board connected to the internet, I think. I don't think anyone else can just go to that code, but if you can, it's not going to be connected to it for very long anyway. But yeah, so now I've got that connected, and if I click the button at the top here which says light on or light off, LED is off and the LED is off. I know you can't see that at the moment, but if I click the on button, the light does indeed come on, and when I click the off, it goes off. So let me show you on the bench exactly what you got. I shall once again now click the on button, and the little LED has indeed come on. I assume you can see it. I've got something covering my bit of screen there. There you go. You can see it in the shade there. So if I then click on the off button, if I can find my mouse again, there it is. If I click the off button, it goes off. I can click the on button, it comes on again. Off and on. Now, although this is connected to the computer, that is purely providing power to it at the moment. It's not actually connected electronically. Well, it is, but you know what I mean. And it is indeed still reading back, giving me the temperature 27.9. It's been under the lights a little bit longer. So, yeah, I'm happy. I understand how that works. It would be nice if this was powered externally, but for now it isn't. but it does teach me that that is working. So that, in theory, I can send the LED thing, but I can send anything else to it as well. I could get it to control a motor, or indeed other sensors connected to it as well. So I'm happy that that is working as that says it should work. So yeah, I'm sure he will go on to say more things can be plugged onto it and everything else, but I don't need that. It's running a web page on this tiny little board like that. It's quite impressive, isn't it? So I shall complete that bit, and that indeed completes. I'm only 95 complete on there. Why am I only 95% complete? What have I not done? Done all of them. Done all of them. I'm not done. It says 100%. It's 100%. Why is it only saying 95? That's not right. Let's go back to my courses. See if it's updated. It's updated now. It says 100%. Good. I'm happy with that. So yeah, the 30 Days Lost in Space is apparently not updating, but I've done all of that as well. But I'll go back and do it again because they've updated the course quite a lot. So there is an AI they're developing to help out with that. So I'll have a look at that. But next, I will be tackling the Nebula Raiders because I've already started on Python. So I may as well continue with Python with, it's actually the same board, but I've got that in the other kit. So this was the Neon Realm, the beginner's course with 10 days worth of work in it. Next up is Nebula Raiders, which is substantially bigger. As you can see, this is a 30-day challenge, similar to the Lost in Space one, but different. And indeed, in the box is a big plastic box, as opposed to just being a box full of bits. But this really is a box full of bits. We've got so much in here. It is going to be lovely. I'll have a go through it properly when I start the course very soon. The breadboard that I've been using for this one, because it's just nicer and bigger. We've got all sorts of jumper cables, stickers, RFID, keypads. It really is a box full of stuff. There's screens. There's even more LEDs and buttons, remote controls, servos, tiny buttons, more resistors, water sensors, infrared movement detectors, some sort of gyroscopic sensor, I think. Lots of different types of LEDs and buttons. Another Pico W board, which is going to be always lovely to have them. And we've got a motor. We've got lots of cables, proximity sensors, different LED settings of different shape panels, 7 segments, and a single 7 segment. Switches, a bit for the motor, a fan, and a relay, I believe that is. So yes, lots of stuff. I'll go through it in my first look at this kit. When I start this kit soon, the video will be appearing soon as well. Stickers. It's always nice to have stickers, isn't it? So yeah, join me for that very soon. And for now, I'm going to call that a night. So thank you for helping me through the Neon Realm. I hope you've enjoyed it. And I shall see you for more electronics kits very soon. But thanks for watching. Stay safe. I'll see you soon. Bye-bye for now.